Again, we are setting up creating a lab setup here just so that we can perform Nmap scans on it. Right. So again, for Windows, you need memory 2 GB, processor, one processor, network adapter, bridged adapter. Click on OK, and now click on power on. So this is our setup here. One Kali system, one Metasploitable, and one Windows 7. Okay. So now we're going to start with the Nmap practical. So this is the setup required to get started with Nmap. I'm going to log in here. Now for Metasploitable, guys, the default credentials are mentioned here itself, msfadmin/msfadmin. And if this is too small, you can click on this button here. This expands the or enlarges the screen. And now you can type username msfadmin. And password is also msfadmin. We don't have root user access yet. In the upcoming sessions, we'll learn how to get root user access by attacking this machine. Okay. So right now, if I type ifconfig, you can notice this machine is getting an IP 192.168.0.6. And my Kali system here, on the other hand, should be getting an IP in the same network. So whenever you want to move from one machine to the other machine, guys, you can press Control and Alt. That gives you your base machine's mouse cursor. And you can press Alt and Tab to shift from one machine to the other machine. Okay. Or Control and Tab. Control Tab also shifts you from one machine to the other machine. Okay. So Control Tab, I go to my Windows, workstation home screen. Control Tab again, go to Kali. Control Tab again, go to Metasploitable. Control Tab again, go to my Windows 7 here. Okay, so you can always move. But before you press that Control Tab, you have to press Control and Alt to get your mouse from the Windows base machine cursor. Okay. Only then you can shift from one tab to the other tab. Okay. Or alternatively, there's one more method as well. Again, you press Control and Alt first so that you get the cursor from the base machine. So unless and until you get the cursor from the base machine, you can't use Control and Tab. Okay, right. So now moving forward. Yeah, 1 second, guys. You should actually be getting one more screen over here on the tab. You should get a pinned option. Actually, I'm not getting that for now for some reason. Yeah, now I got it. So you can select this pin as well here. When you select this pin, this keeps on staying. So from here also you can click on each of the tabs. That's another better alternative to shift from one window to the other window. So this is always pinned. This won't hide itself. And you can jump from one machine to the other machine just with one single mouse click. That's also another alternative. Okay. So that's one thing. So you just keep this window pinned over here so that it doesn't hide itself. Okay. Now, first things first, I'll open up my terminal here. And if I check my IP address, this is 192.168.0.7. My Metasploitable is 0.6. And my Windows 7 here, this is 0.8, as you would notice. Okay, so these are all machines in the same network here. Okay. And now to perform the first Nmap scan, I can just come back to my terminal or my Windows presentation screen here. And the first command we're going to learn is the ping scan. Ping scan is to perform host discovery to figure out in your network what all devices are active. So in order to perform the ping scan, the syntax is nmap, and then you mention the scan type. And then you can mention a single IP or a multiple range of IPs, or again, you can mention a domain name as well. So the scan type right now for ping scan is -SN for ping scan. Okay. And then you can scan a singular IP. Let's say if I want to scan my router, I can specify my router's IP here, 192.168.0.1. And now when I hit enter, it gives me the results here. So let me break down the results. So it says starting nmap, so-and-so version at so-and-so time. Nmap report for the IP which we just scanned, 192.168.0.1. And it says host is up. So it just tells you if the device is available and active in your network or not. Okay. And this is the vendor of the device. So this is only scanning one single IP at the moment. But if you want, you can scan your entire network as well. So if I type nmap, and for ping scan, the option is -SN, and the entire network now 192.168.0.1 hyphen 255. This is one method of scanning the entire network. Alternatively, you can also mention it with CIDR /24. So if you remember in the networking class, we discussed about CIDR values. For class C, it is /24. Okay. So you can either mention it this way or 1-255. And now when you hit enter, it will scan the entire network now, all the 255 IPs, and tell you how many devices are up in the network. So right now there are 5 devices active. Okay, 0.1 is active, 0.5 is active, 0.6 is active, 0.8 is active, and 0.7 is active. Last IP shown is always your Kali systems IP. And you can notice it shows 6 and 8 as active, which are virtual machines, VMware. Okay, so this is called host discovery, trying to figure out in your network what all devices are active in it. And for that, you have to use the option -SN for it, ping scan. Okay, is that clear, Charles? Vamsi, any questions? Right. Vamsi, any questions on your end? No, not sure, Charles. I think he's away from the computer, or his mic is not working, maybe. Not sure. But anyways, moving forward, let's talk about the next scan type, which is TCP Connect scan. Now, this is a scan type to figure out in your device, in your target system, what TCP ports are open. Okay, so for TCP Connect scan, the option is -S capital T. Okay, so if I go back to my terminal here, now if I want to perform the TCP Connect scan on my machine, Metasploitable here. So Metasploitable is on the IP 0.6. So to perform a TCP scan on that, the command would be nmap. For TCP Connect scan, it is -S capital T for TCP Connect scan, and the target IP 192.168.0.6. And now when I hit enter, this is the result for it. Okay, so it scans the target system and gives me a list of all the TCP ports on the target device. Okay, let me break down the results again. So it says starting nmap so and so version at so and so time, nmap report for the IP that we have mentioned. First, it performs a ping scan and tells you that the device is active. And then it says not shown 977 closed ports. So an important point to note here over here is nmap scans for most important 1,000 ports. So out of all the 65,535, it selects the most important 1,000 ports. And out of those 1,000 ports, it now tells me 977 ports are closed. And the remaining 1,000 minus 977, that's 23 ports. So the remaining 23 ports are shown as open here. So it shows me the port number, it shows me the state of the port, open or closed, and the service running on that port. So port 21 is open on the target system, running FTP service. 22 is open, running SSH. 23 is open, running Telnet. 25 is open, running SMTP. 53 is open, running DNS. So it specifically tells me which ports are open and what services are running on that port. So this is a TCP Connect scan, telling you what TCP ports are open on the target device. And the scan took around 0.24 seconds to complete, is what it says. Okay, so this is what TCP Connect scan does. Used to scan TCP ports on the target system, and in the process, it performs TCP three-way handshake on each port. Okay, there's one more scan as well called SYN scan. Now, if I run the SYN scan, carefully observe, I'll open up another terminal here side by side. And now when I type nmap -S catalyst for SYN scan and the target IP 0.6, let's say, and if I hit enter, carefully observe. Yeah, oh, let me minimize this a bit if it's still not. Just 1 second. Yeah, much better. So if you notice over here, I ran TCP scan over here and map-st TCP scan, and I ran the SYN scan over here. And if you carefully observe, the output is pretty similar. There's no difference at all. 977 closed ports, 977 closed ports, same number of TCP ports shown here, same number of TCP ports shown here as well. But now the question that arises is, if we have two same outputs, why two different scan types? Okay, now if you notice over here, the one difference that we notice is here it shows reset and here it shows connection refused. Oh, sorry, it's hiding itself. Yeah, connection refused. Okay. Now, what does it mean by connection refused and what does it mean by reset here? To explain this, let me show you a diagram. What happens in TCP Connect Scan is, as mentioned earlier, in TCP Connect Scan, it performs a TCP three-way handshake on each open port. Okay. So if I draw this out, there's my browser. Yeah. So what Nmap does in TCP scan is if this is my Kali system here, which runs Nmap on it, and if this is my target here, and whenever there's a port open here, what my Kali system does is it sends a SYN flag first on that port. Okay, to figure out if it's open or not, it sends a SYN flag. In return, if the port is open, that port sends back a SYN ACK, right? If the port is closed, it sends a reset. But if it's open, it sends a SYN ACK. So with this SYN ACK, the job is actually done. Nmap got to know the port is open with that certain response. Yet, even after receiving a SYN ACK, my Kali machine still sends an ACK flag, ACK. So this SYN ACK and ACK is nothing but your TCP three-way handshake. And whenever a TCP three-way handshake is performed, what happens? A log is initiated and the target system knows that someone connected on that port. Okay. So this is what happens in the TCP Connect scan. It performs a TCP three-way handshake. Now, on the other hand, in the SYN scan, this is not the case. So again, there are two machines here, let's say. What happens in SYN scan is first it sends a SYN flag on the port. And if the port is open, it receives a SYN icon back in return. And with that SYN ACK, the job is done actually. So now after the SYN ACK is received, it doesn't send an ACK flag now. It directly sends a reset flag, RST. Okay, and it rejects the three-way handshake. It stops the three-way handshake in middle, doesn't complete connection establishment. That's why it shows a reset over here, if you notice. Okay, because it is sending a reset flag in the end. It is not refusing the connection, it is resetting the connection altogether. Okay, so after SYN ACK and ACK, then it sends a reset flag in TCP scan. This is called connection refusal. Okay, but this is waste because it has already performed the connection here. So that is useless now. So here, rather than sending an ACK, it sends a reset flag and terminates the connection midway. That's why it is also commonly known as half open scan. Okay, or stealth scan. The reason why it is called stealth scan is because it doesn't perform the TCP three-way handshake. So the target doesn't know who performed the scan on the target system. Okay, so that's why this is called as TCP Connect Scan over here. This is TCP Connect Scan, or also commonly known as full scan. These are the names given to the scan type. Okay, and on the other hand, this is known as half open scan, or stealth scan. Okay, or your SYN scan. Okay, these are the names given to the scan type. Is this clear, everyone? So even though the results are same, the mechanism of the scan is different here for TCP Connect scan and SYN scan. Okay. Any questions? Hello? Right. Definitely. Definitely. No worries, Charles. So now when we try to perform an Nmap scan, let's say, so this time when we perform an Nmap scan, and if I don't mention any scan type, let's see what happens then. So if I just mention Nmap and a certain IP, and if I hit enter, you can see over here, it shows reset, which indicates when you don't use any scan type, Nmap by default always uses the SYN scan. Okay, so that's an important question, or a question asked in interviews as well. What happens if you don't mention any scan type at all? In that scenario, Nmap always goes for the default SYN scan. Okay, it shows reset over here. Okay, moving on to the next scan type, there's UDP scan as well. So again, for TCP ports, we have SS and IST. But for UDP ports also, we need a certain scan type. So for that, it is SU. So if I open up my terminal, and if I type nmap -s capital U for UDP scan, and if I specify the target IP, now this should give me the UDP port results. So now when I hit enter, you can see this initiates the UDP scan. But does anyone find something fishy here? Does something look odd to you over here? Is something wrong with this scan? Yeah. Do you find something fishy in the scan? Do you find something very odd or very different? Something that has. No, no, no. That is just the time zone. Nothing with that. But if you remember, Nmap works on the basis of TCP flags, right? So it sends SYN flags and tells you which ports are open and which ports are closed. But in UDP, you don't have any flags at all. Then how is Nmap performing this scan? Is the question, right? So that is something odd over here. So Nmap is also performing a scan on UDP ports, but Nmap predominantly works on the basis of TCP flags. And that is why you can notice it's taking too long over here. Reason being, Nmap needs to generate a special packet for every UDP protocol. And that is a time-taking process. So over here, if I stop the scan, Control C to stop it, I can now run this with an option called -v for verbose, SU, same IP. And if I add -v in the end, it now gives me extra details of what is happening in the scan in the background. V stands for verbose to give you detailed output of the scan running. Okay, rather than you getting a blank screen now, it tells you from time to time how much scan has completed and what is happening in the background. Okay, so it says starting nmap so and so version at so and so time. It started a ping scan first, figure out that the device is active, and then it is scanning 1,000 important ports. Okay, and until now, only 3% of the scan is done. Estimated time for completion, it's going to take 11 minutes more. Okay, so Nmap needs to send a packet for every single port on UDP with its own specialized packet, specially crafted packet. And that is a time-taking process. Your TCP scans are usually done in 1 second or 2 seconds or so, not more than that. But UDP scans take at least 12 to 15 minutes to complete. Okay, and that is the difference between a TCP scan and a UDP scan. Okay, is that clear, guys? Definitely. Very longer time because the reason being nmap has the tcp flags, so it sends a SYN flag, receives a response back instantly for tcp. But in udp you don't have any flags at all, so when it doesn't have flags to scan, it needs to send a special packet for every protocol, and that crafting of that special packet, creation of that special packet for each protocol and waiting for a response in return takes a while. So that's why udp scan takes much longer compared to a tcp scan. But nevertheless, you still got to wait for the results and see what UDP ports are open as well to perform complete pen testing. Okay. So this is an assignment for you once the class is done. Again, this is the last scan for today's class, nothing further anyhow. So what I want you to do is set up your machines, Kali system and Metasploitable system and the Windows 7 system. And I want you to perform the UDP scan on the Metasploitable and show me the results for it in the next class in tomorrow's session. Okay. So this scan. No, you can just take a screenshot of that end result and show me the output for it, Charles. Okay, just take a snapshot or a screenshot and show me the end result of what the UDP ports were open on the target. Okay. So once you perform the scan, this is something, the output would be something like this. So and so port number, so and so UDP ports, and it shows them open or closed. Okay. So that should work. Right. Moving forward, now again, as mentioned, nothing else for today's class. I think I've already shared this documentation with you, but I still have to share the virtual machines, Metasploitable and the Windows one, and I'll share that now. Okay. Any questions before we exit, Charles? One, see. It might get slightly more complex as we progress, Charles. So, but don't worry, I'll try to explain. I understand. No worries. Again, it's not that tough either. I've been in this domain for the last 5 years, so again, it seems a bit simple for me. But with practice as well, it gets a lot easier. Uh, Shaz, that's okay. It's okay. Once you refer it back again, it gets stuck. Right. So yeah, I've added all your emails. I'm sending this file to you now. You can download these VMX files. And again, as mentioned, install it in your VMware setup and perform the Nmap practical on that. Okay. That's that. Nothing further for our session today, guys. Let's disconnect here and connect back tomorrow at the same time to continue further on Nmap. Bye-bye. Thanks, guys. Bye.